Now we are going to discuss about the ideal gas equation, which is PV equal to nRT, where P is the pressure of the gas, V is the volume of the gas. Volume of the gas is the volume of the container, N is the number of moles of gas, R is the universal gas constant, and T is the temperature in Kelvin. Now we can write mole as given mass by molar mass into R into T. So we can rearrange this equation as W by V, which can be written as Pm equal to dRT. Given mass by volume is known as the density of the gas. So the equation will become Pm equal to dRT. Now the different values of the R is 0.082 liter atmosphere by mole Kelvin, 8.314 joule by mole Kelvin, and 2 calories by mole Kelvin. So now which value should we prefer? We should prefer firstly that is 0.082 liter atmosphere by mole Kelvin, because generally pressure is given in the units of atmosphere and volume in the units of liter. So the density would be in the units of gram per liter, and m is the molar mass of the gas, which is given in the units of gram per mole. R universal gas constant, T is the temperature in the Kelvin. Now we are discussing the problem in which to an evacuated vessel with movable piston under external pressure of 1 atm, 0.1 mole of helium and 1 mole of an unknown compound of vapor pressure 0.68 atm at 0 degree was introduced. Considering the ideal gas behavior, we need to find out the total volume of the gases at 0 degree. Now the given is external pressure on the movable piston is 1 atm and the mole of helium gas inside the cylinder is 0.1 mole and an unknown compound is 1 mole. The vapor pressure of this unknown compound is 0.68 atm. We need to find out the volume of the gases. Volume of the gases is the volume of the container. So we need to find out the volume of the container with the use of the ideal gas equation, that is PV equal to nRT. Now the partial pressure of helium gas can be found out by subtracting the external pressure on the cylinder piston, that is 1 atm, and 0.68 is the vapor pressure of the compound. So the pressure of helium gas is 0.32 atm. Now by the use of the ideal gas equation, that is PV equal to nRT, if we use the pressure of the helium gas and V is the volume of the gases, then N is the mole of the helium gas, R is the universal gas constant, and T is the temperature in Kelvin. We can find out the value of the V. So volume V is, by the simple calculation, V comes out to be 7 liter. So the volume of the helium gas is the volume of the gases.